Hello everyone, myself Dr. Pradeep Kumar MR, working as Assistant Professor in the Department of Pharmaceutical Chemistry at KLE College of Pharmacy, Hubli. In this session, I will be discussing on the topic anti-neoplastic agents. Let us see the definition. Antineoplastic agents are the drugs used for the treatment of cancer or malignancy or tumor or carcinoma or sarcoma or leukemia or neoplasma. The term neoplasma is basically is formed from the two Greek terms, that is neo and plasma, where neo means new and plasma means formation. It refers to a group of diseases caused by several agents, namely chemical compounds and radiant energy. Let us see the limitations of cancer therapy. First, cancer cells very rapidly develop resistance to antineoplastic drugs. Second, differences between normal and neoplastic human cells are merely quantitative. Third, biochemical and morphological differences between normal and neoplastic cells are slight. Therefore, antineoplastic agents are devoid of selective toxicity to tumor cells. Antineoplastic agents kill cells by first order kinetics, that is, they kill a constant fraction of cells. However, some of the cancer cells elude killing and one of these cells may restabilize the tumor. It is extremely difficult to kill all the malignant cells. So, this is with respect to the limitations of the therapy. Let us little bit know regarding the present scenario, which is with respect to the cancer. So as per the WHO report, nearly 9.6 million deaths have taken place globally due to the cancer, and this is considered as a second largest death which is occurring with respect to any disease. So we can understand how dangerous this disease is, and very important thing to know in case of the cancer is the drugs which are useful in the treatment of this cancer are still under developing stages. There is no a specific drug available for the treatment, so but many drugs are under trial, and it's all because the cancer can be treated very well if it is diagnosed early. If it is diagnosed in the later stages, that is nearly the end of the second stage or in the third stage, it is very difficult to cure the cancer. In very rare cases, there are incidences where the patients have cured from the cancer, but it is very rarely possible when the cancer reaches the last stage. Most antineoplastic drugs are highly toxic to the patients. Coming to the adverse effects associated with use of anti-cancer drugs, there is one more big problem associated with the cancer therapy is the drugs whatever are employed for the treatment of the cancer, they are having some serious side effects on the human body. So, what are they, and the drugs which are quite commonly employed for the cancer treatment, how and what type of the toxicity they produce in the body? Let us see one by one. Bone marrow toxicity. This is caused by bleomycin L-asparginase, which are used for the treatment of the cancer. The second type of the toxicity is hair follicle toxicity, which is caused by the anti-cancer drugs like methotrexate, vincristine, doxorubicin, and also cyclophosphamide. Next is hepatotoxicity. It is caused by some anti-cancer drugs like azathioprine, mercaptopurine, and L-asparginase. There can be skin rashes which are due to the treatment with the zinc alkaloids, nitrosuria, anthracyclines, and mitomycin C. There may be pulmonary toxicity which results due to the use of bleomycin or methotrexate or busulfan in the treatment of the cancer. Many times there may be cardiac toxicity which is caused due to the use of doxorubicin, daunorubicin, and anthracyclines. There are some other toxicities like intestinal epithelium and central nervous system toxicity, nephrotoxicity, immunosuppression, anaphylaxis, cataracts, hemolytic anemia, pancreatitis, pituitary insufficiency or adrenal insufficiency, coagulation problems, suppression of growth. Now, before we could go into the study of the different anti-cancer agents available for the treatment, let us just see one by one these classes. So in that, the first class is alkylating agents. So as the name itself suggests, they will bring about the alkylation and they thereby act as anti-cancer agents. Let us see the other classes of the drugs. The second type is antimetabolites. The third one is antibiotics. Fourth type is plant products. Fifth, enzymes. Sixth, hormones. Seventh, immunotherapy. Eighth, monoclonal antibodies. 9. Radiotherapeutic agents. 10th class, cytoprotective agents. And the last class, that is 11th class, is miscellaneous agents. Now let us go one by one in the study of these. As already we could see here, the first class is alkylating agents. As I said, they bring about the alkylation and thereby they will act as anti-cancer agents. So the alkyl groups will get attached to the DNA moiety, thereby they will bring about the changes in the DNA structure, thereby the proper DNA synthesis which need to take place will be inhibited, thereby they will act as a anti-cancer agents. The examples of the drugs belonging to these classes are mentioned here. So these alkylating agents are further subclassified into different types, in that the first one is nitrogen mustards. The first subclass under alkylating agents is nitrogen mustards. Examples are mechloroethamine, ifosamide, cyclophosphamide, melphalan, uracil mustard, and the structure for the same drugs has been mentioned here. Few more drugs belonging to that class are estramustin and chlorambucil. These are the structures for the respective compounds which belong to the class of nitrogen mustards. The second subclass in the alkylating agents is alkyl sulfonate. The example for this class is busulfan, and the structure is mentioned here. And the third subclass is nitrous ureas. The general structure is shown here, containing R, whereby down in the tabular column you can see, based on the different substitutions which are done at the place of R, we are having the different compounds belonging to the class of nitrous ureas. Some of the examples are carmustine, lomustine, semustine, and chlorogotocin. Next, the fourth subclass is aziridines. The fourth subclass is aziridines. Examples of the drugs are thiotepa and benzotepa. Structures you can see there. Then comes the next subclass is altratamine. So under that we are having the four drugs as shown here. The first itself is altratamine itself, and the second drug we can see the 1,2,4-dinitrophenyl aziridine. Then the third one is trithylene melamine, and the fourth one is 4,1-aziridinyl 2,6-dimethoxytriazine. The structures for the respective compounds are mentioned here. Coming to the next subclass under the alkylating agent is methyl hydrazines. The examples for methyl hydrazines are procarbazine and decarbazine. So they are containing the methyl hydrazines moiety, as you could see there, CONH group attached with the methyl moiety. Coming to in general the mechanism of action of alkylating agents. Later I will be detailing completely with respect to the mechanism of action. Just here we briefly will try to know the mechanism regarding the alkylating agents. Whenever alkylating agents are consumed, in the first step they undergo the intramolecular cyclization. As you could see here, the branched chain has got converted into the cyclized form. In the second step, the nucleophilic attack of unstable aziridine takes place, where you can see there the cyclized unstable form of the aziridine, what we have seen as one of the class aziridines, is taken here as an example. It will bind with the DNA, as you could see. So it will bring about the change in the structure of the DNA, and thereby it will inhibit the DNA synthesis, and in turn it will inhibit the cancer cell growth. Next, we move on to the second main class, that is anti-metabolites. In this, we are having again few subclasses. The first subclass is pyrimidine analogues. Examples include 5-fluorouracil, then capectitabine, then floxuridine, then the one more compound is cytarabine. So as you could see there, basically they are containing the pyrimidine nucleus. Along with that, they are having few substitutions which look like the analogues to the usual pyrimidine bases, which play a vital role in the DNA synthesis. So these compounds will compete with the natural pyrimidine bases to get entry into the DNA synthesis, where by competing with the actual pyrimidine bases, they will try to take up their place, but due to their entry in the DNA synthesis, the DNA synthesis doesn't take place. Maybe they are the analogues, but they are incapable to play the role of the natural pyrimidine analogues. Thereby, the DNA synthesis is inhibited. So, these are the compounds what I just referred with respect to the floxuridine and cytarabine, which are the pyrimidine analogues. Coming to the second subclass of antimetabolites is purine analogues. As all of us are very much familiar, the purine and pyrimidine bases involvement in the DNA synthesis, like the pyrimidine analogues what we have seen, how because of their close resemblance with the natural pyrimidine analogues, they will compete and bring about the DNA synthesis inhibition. Similarly, the purine analogues do the same. Due to their structural similarity, they will compete with the usual purine analogues, that is purine bases. Thereby, they will bind at the actual places where the purine bases has to bind, but maybe they are resembling, but functionally they cannot perform the same type of the activity what the usual purine analogues used to perform. Thereby they will inhibit the DNA synthesis, thereby the cancer cell synthesis too. Some of the examples, as you could see there, the first one 6-mercaptopurine, the second one 6-thioguanine, and the third one fludarabine. So these are the three important compounds belonging to the class of purine analogues acting as antimetabolites. Then come to the next subclass among the antimetabolites is folic acid analogues. Here we are given the general structure where in the place of the R, if we replace the R with the hydrogen atom, it will give rise to a compound that is aminopterin. If the R is replaced with the methyl moiety, it gives rise to methotrexate. Both are folic acid analogues. Next, few more compounds are azathioprine and triantrexate, which also acts as antimetabolites. Let us see the mechanism of action of antimetabolites. So, as we have seen in general, there are three different types of antimetabolites or the three subclasses of antimetabolites. Let us see the first compound, that is first type of the subclass, that is pyrimidine analogues, and their way of acting as anti-cancer agents. Let us see the mechanism of action. These are the analogues that resemble normal compounds of coenzymes which participate in the DNA synthesis and competitively inhibit the utilization of normal substrate or gets incorporated to make dysfunctioning. So this is the function associated with the pyrimidine analogues. Coming to the purine analogues, these drugs are converted into appropriate monoribonucleotides which inhibit the conversion of inosine monophosphate to adenine and guanine nucleotides. Coming to the mechanism of action of folic acid analogues. These folic acid analogues inhibit DHFRase, that is dihydrofolate reductase, which converts the dihydrofolic acid to tetrahydrofolic acid, the coenzyme required for one carbon transfer reaction in de novo purine synthesis and amino acid interconversion. Let us move on to the next class, that is the antibiotics. It is actually the third class, antibiotics, where the first subclass is anthracyclines. As you could see there, they are generally having the tetracycline type of the structure, and based on the different substitutions, what you could see in the general structure, that is R1, R2, R3 and R4, the different anthracyclines are available as antibiotics which are preferentially used to treat the cancer. So based on the different substitutions, as we could see in the place of R1, R2, R3 and R4, we are having the different drugs like daunorubicin, doxorubicin, carminomycin, idarubicin and epirubicin. So commonly you can see there the R1, R2, R3, R4 have been substituted with methoxy group or hydrogen or hydroxy group. Few more belonging to that are valrubicin, You can see the structure here. Similarly, the next drug is bleomycin. So previously, the structures what we have seen in the general, with respect to the general structure, those drugs were commonly having the structure which is quite same in all the drugs with slight changes with respect to R1, R2, R3 and R4, whereas valrubicin and bleomycin what we are seeing here, they are having lot many changes with respect to the substitution. So these two drugs have been taken for study separately. With respect to bleomycin, you can see there are three different types. Bleomycinic acid, where R will be hydroxy group, whereas bleomycin A2 and bleomycin B2, based on the different substitution at the place of R, they are having the different structure, but commonly these three are the different variants of the bleomycins group only. Moving on with the next type of the antibiotic, that is mitomycins. Amongst that, we could see the examples are mitomycin C, the respective structure is given, then dactinomycin C, or it is having one more name, that is actinomycin D, then plicamycin or mithramycin. Coming to the next class, that is plant products. So as all of us are very much familiar, plants are the major compounds which contain a very good agents which we are referring as a phytoconstituents, which are naturally occurring and useful for the treatment of various diseases, not only with respect to cancer. In case of many diseases, the phytoconstituents or the medicinal compounds available from the plants are very well employed in the treatment of many diseases or disorders, and it is also true for the cancer also. So there are many plants which contain some therapeutic agents or the phytoconstituents what we refer as, which are very much effective in the treatment of cancer. So amongst that, the first one is vinca alkaloids. So here I have shown you the general structure of the vinca alkaloids, where the two important types are vincristine and vinblastine. These are the two vinca alkaloids obtained from the plant Vinca rosea. So if R is substituted with the aldehydic functional group, it becomes vincristine, and if R is substituted with the methyl group, it becomes vinblastine. So this is a small change with respect to the two different phytoconstituents from belonging to the class of vinca alkaloids. Coming to the second type, that is camptothecin derivatives. The general structure has been shown here. Here you can see the tabular column based on the R and R dash substitutions. we are having the different derivatives like camptothecin, irinotecan, and topotecan. All these three drugs, which are the camptothecin derivatives, are very effective in the treatment of the cancer. The next type is Epipodophylotoxins. The general structure is given here. There are two types, that is etoposide and teniposide. You can see based on the different substitution, that is if the R is substituted with the methyl moiety, it gives rise to a etoposide, one type of the epipodophylotoxin. And if R is substituted with the thiophene heterocyclic ring, it gives rise to teniposide. Coming to the next class, that is subclass Taxol derivatives. Taxol derivatives. You can see the structure, it is a general structure, and one thing I just want to bring it to the notice, all these plant products what we have studied, commonly you have seen that they are having very complex structure, starting from the wing alkaloids we have seen. So you need to carefully observe their structure. So coming to the Taxol derivatives, based on the different substitutions at R and R dash, we are having the two different types, that is paclitaxel and docetaxel. Now let us see the mechanism of action associated with the plant products. Generally, how do they act as anti-cancer agents? These phytoconstituents what we studied in under the different subclasses here, they will show their anti-cancer property by binding to the microtubular protein tubulin. I will repeat, they will bind to microtubular protein tubulin, and thereby they will prevent the polymerization and assembly of microtubules, and thereby they cause mitotic spindle destruction. The chromosomes fail to move apart during mitosis, and finally it will lead to the metaphase arrest. So once the mitotic spindle destruction takes place, the usual process of, that is the chromosome should get separated, will not take place, and that is what the main thing happening in the mitosis stage. Once this stage is blocked, automatically the cell division what we are referring, it will get arrested at the metaphase itself. So thereby the growth of the cancer cells is prevented, and this is how the plant products or the phytoconstituents whatever we have just studied, they act as antineoplastic agents or anti-cancer agents. Now let us move on to the next class, that is enzymes. There are quite good examples where enzymes do show the very good efficiency in treating certain diseases. No doubt we know that enzymes are the biocatalysts. They catalyze the biochemical reactions. They also play a vital role in the treatment of certain diseases, and that is true also with the cancer. Examples of enzymes include L-asparginase and Pegaspargase. I have just shown you the L-asparginase structure, that is L-aspargine I have shown. So it acts by, these enzymes acts by breaking down the amino acid known as aspargine, without which the cancer cells cannot make protein. Like how the natural cells make their own protein, which is utilized for their growth and repair process. Similarly, even the cancer cells also try to make the protein for their survival, but the due to this, that is, they break down the amino acid which is referred as aspargine. When it is not available to the cancer cells, they cannot synthesize the protein, thereby their multiplication is blocked. And this is how the enzymes show the anti-cancer property. This is just an example where by taking the L-aspargine, their activity is explained. So here whatever the activity of the enzyme is there, that is with respect to L-aspargine, is mentioned here. Next type of antineoplastic agents, that is next class, is hormones. So there are different types of the hormones which are used as antineoplastic agents. The first type is estrogenic derivatives. Estrogenic derivatives. At the top right corner, you can see the general structure where you can see the general structure containing R. So if that R is just a proton or a hydrogen, then it is referred as a 17 beta estradiol. Very useful anti-cancer agents. And if R is equal to, that is, you can see the alkyl moiety, acetylene moiety. So it gives rise to a compound that is ethinyl estradiol. The second example is diethyl stilbestrol. It is a non-steroidal drug. As you could see, why I am stressing upon, just see the structure of the above one, estrogenic derivatives. Here, so diethylstilbestrol, I have just mentioned it as a non-steroidal drug. This is its structure, as you could see here. So it is not containing a steroidal nucleus. So the general structure of the steroids, that is 3 benzene rings fused to each other, which is in turn associated with a 5-membered ring, that is what we are referring as a ABCD rings, which are fused with each other, which is a basic structure of all the steroidal moiety, is absent in case of this diethylstilbestrol, but it is also belonging to the category of that this one hormones. But since it is lacking with the steroidal nucleus, we are referring it as a non-steroidal drug. Coming to the next class, that is progestin derivatives. So here you can see the structure of the progestin derivatives. You can see the structure. Few more examples belonging to that are, that is first one what I shown, it was a progesterone. Now I am showing you the one more moiety, that is the derivative of that is hydroxyprogesterone caproate, where you can see the R1 and R2 are associated with the different groups, because of which it is a derivative of the progesterone. That is the previous one what we have seen, its derivative it is, and one more derivative is medroxyprogesterone acetate. Then we can see the next one, that is megesterol. This is the structure of megesterol. Coming to the next class of hormones is testosterone derivatives. Again you can see there, first I have given the general structure of the testosterone, that is general structure we can't tell, that is a testosterone hormone, it is its structure, and below that you could see the derivatives of that. They have brought about small modification by the substitution of certain functional groups which have shown a better potency as anti-cancer agents in this case. So they have been brought under this category, where we are generally referring it as a testosterone derivatives. This is the structure of testosterone, and these are the examples of the derivatives of the testosterone, that is testosterone propionate, the first one, the next one is testolactone, and the third one is cyproterone acetate. Then comes the next class, that is steroidal anti-inflammatory agents. So you can see here the drugs or the compounds which are referred as an example under this category are prednisone and flutamide and their respective structures. Coming to the next subclass is miscellaneous agents. Examples include the first one mitotane, next one tamoxifen, and the third one aminoglutathione. So these are the respective structures for the mentioned compounds. Few more classes are, the sixth one is immunotherapy, where immunoglobulins are given to the patient whereby they are helpful in the treatment of the cancer. Examples include interferon alpha 2A, interferon 2B, interferon alpha N3, aldesleukin, diphthitox, denyleukin, and bacillus calmette-guerin. That is what we are referring as a BCG, that is bacillus calmette-guerin. Then the next main class is monoclonal antibodies. Examples include rituximab, gemtuzumab, ozogamicin. Then the next main class is radiotherapeutic agents, that is radioactive substances used as therapeutic agents, we are knowing already the specific radioactive substances which are used in the treatment of the cancer is mentioned here. They include chromic phosphate P32, sodium phosphate P32, sodium iodide I-131, strontium 89 chloride, samarium SM153, lexidronum. Then the ninth class is cytoprotective agents, that is mesna as an example, amifostine and dexrazoxane. And the last class is miscellaneous. Cisplatin and carboplastin are the drugs which belong to the class of miscellaneous, where many a times it has been explained with respect to other chapters also. Miscellaneous type of the compounds what we are studying, no doubt they are having the mentioned activity because of their no resemblance with any other class of the drugs in their structural pattern. They are categorized as a separate group, that is as a miscellaneous group. So the examples include cisplatin and carboplastin. So here we can see some of the compounds what we have referred as cytoprotective compounds. Imatinib, the first one, that is a tyrosine kinase inhibitor. This is the structure for that. Then the mesna, it is a cytoprotective agent. This is the structure of the mesna. And here we can see the dexrazoxane, which is a cardioprotective agent, because already we knew that the cancer therapy where we are using certain compounds, no doubt they are good anti-cancer agents, but they are having some deleterious effect on the different organs of the body. So because of that reason, along with the cancer therapy, we try to make use of these cytoprotective agents which will try to nullify or at least minimize their severe toxicity on the different organs, because it is a known fact that treatment is the first option. So even though there are little bit side effects can be considered, because the life of the patient is very important. For that reason, we can't avoid the use of the anti-cancer agents whatever under the different class we studied. But meanwhile, we should also see that they should not do some serious damages to the other organs, which is again incorrectable, that is which cannot be correctable. Like that, it should not happen. For that reason, in order to protect the severe toxicity of these drugs, we try to make use of certain cytoprotective agents which will give the protection against the toxicity these drugs are inducing on the different organs during the treatment. Now let us see one by one the different synthesis of anti-neoplastic agents. Amongst that, the first one is synthesis of chlorambucil. As you could see here clearly, here we are making use of the two starting materials, that is, one is para-aminophenyl butyric acid, which is treated with ethylene oxide. So when these two reactants undergo the reaction, there is a formation of an intermediate which further on treatment with the thionyl chloride gives rise to the final compound of our interest, chlorambucil. Next is synthesis of busulfan. This is the reaction where two reactants are employed, that is 1,4-butane diol, that is 1 mole of 1,4-butane diol undergoes a reaction with 2 moles of methane sulfonyl chloride in the presence of pyridine. With the loss of 2 moles of hydrochloric acid, it gives rise to the final compound of our interest, that is busulfan. Now the third compound, that is synthesis of methotrexate. Here, this particular synthesis makes use of the three reactants as a starting material. The first one is pyrimidine 2456 tetraamine. The second reactant is 2,3-dibromopropanol, and the third reactant is methylamine benzoyl glutamate. These three compounds undergo a reaction in presence of barium chloride, that is aqueous barium chloride, sodium hydroxide, and acetic acid in presence of iodine and potassium iodide, where the pH is maintained at 3.1, will result in the formation of methotrexate as the final compound. The next synthesis is tamoxifen. In this synthesis, two starting materials, that is one is 2-ethyl deoxybenzoin undergoes reaction with the 4,2-NN dimethyl amino ethoxyl phenoxy magnesium bromide, and there, when they undergo the reaction, there occurs a nucleophilic addition type of a reaction followed by hydrolysis, which will result in the formation of an intermediate which on further treatment with the concentrated sulfuric acid undergoes dehydration to give tamoxifen as the final product. Coming to the frequently asked questions. What are antineoplastic agents? Classify them with examples. Write a note on alkylating agents. Explain antimetabolites. Give the synthesis of chlorambucil. Write a note on plant products useful as antineoplastic agents. Give the synthesis of tamoxifen. Give the mechanism of action of alkylating agents. Give the synthesis of busulfan. Explain the role of hormones as antineoplastic agents. And the last question is give the synthesis of methotrexate. These are some of the frequently asked questions from this topic where we need to detail the concept as per the question it is asked. We need to explain with respect to the structure, that is chemical property wise, that is chemical nature wise, followed by mechanism of action in depth. Thank you.